All right, this is topic number 15. It's identifying similarity practice. It's basically just going to be, can you check and see what kind of similarity we're dealing with, and how do we actually approach, verifying whether it's, remember, we have three different similarities that we've established so far. We have angle-angle similarity, which is the easiest of the three. Um, it's basically, I just need two angles in order to get two triangles that are similar. The other one that I have is side, side, side. Sorry, that's my dog if you hear that extra jingling. And then the last one is side angle side. Remember, when you do this one, um, you got to make sure that the angle's in the middle. Okay, so let's take a look at this. They didn't give me anything on the first example except I see arrows. And arrows means parallel lines. And whenever I see parallel lines, I try to make letters. In this case, it looks like I can make some F's. So let me go ahead and show you the F that I see going this way. Remember that if I can make an F, that means we have corresponding angles. Corresponding angles are going to be the angles that it catches in that F, which would be that one and that one, which means I have an angle right here. And I can make another F using those parallel lines. I would just go the other way. Also have this F going this way. And when I get the F going that way, that means I catch this angle right here. And that gives me another angle, and that is enough. I have two A's. That's enough to say those two triangles are similar. Remember, we're talking about the little triangle in here, and then the larger triangle in here. So you could have done it this way. Another way that you could have done it is by using the angle that's being used in here, right? Reflexive property says uh, angle C is congruent to angle C. But any of the three would have worked. You just need two. So I can go ahead and say that triangle CBD, that's the little one in here, triangle CBD is similar to triangle, the large one. In CBD, I went yellow to green to pink. I need to go yellow, green to pink on the big triangle. That's going to be CAE by angle similarity. So that takes care of the first one. It's weird because they really went too many marks, but we were able to figure it out from there. All right, on the second one, I do see some sides, so I'm going to go ahead and try to check proportionality. We really have to be careful with this one, just because it is a very, very, really, like extremely weird embedded triangle. So let's take a look at the two triangles that I'm talking about. I got this triangle right here, and then the larger triangle is this one right here. So those are the two triangles I'm going to try to show that are similar. I definitely see some sides, and if you notice, both of those triangles have angle x. So I have angle x on the top. I also have angle x on the top. Those two angles have to be similar. So I get to say that this angle right here, I know that angle x is congruent to angle x because of reflexive property. I'm sorry, guys. I'm so distracted. I don't know if you can hear it. My dog is just walking all over the place. All right, so let's go ahead and keep going. As far as matching up sides, let's take a look at the sides that I have on this little triangle. Out of these two sides on that little triangle, looks like three is the larger one. So on the inside of this one, I'm going to go ahead and highlight this one green because it's the largest side. Now here's where we have to be careful. 3 is the largest side for the small triangle. Now I'm going to look for the largest side on the big triangle. If you think it's this one, you would be incorrect because look, that's 3 plus 1, which is 4. And if I were to look at the other side, 2 plus 4 is 6. So actually, the larger side is on this side of the triangle. So when I go green to green, I'm going to make my fraction 3 and 6. It kind of flip-flops on you, so be careful. All right, let's go ahead and start looking at the smaller sides. I'm going to look at the smaller side for the little triangle, and between 2 and 3, the smaller side would be 2. So on the inside, I'm going to highlight that the small side is 2. And just like we said earlier, the small side for the big triangle, well, this side is 6 and this side is 4. So the small side for the big triangle is actually over here. So when I compare my small sides, I'm going to be comparing the 2 and the 4. Now that I have those two set up, I can go ahead and start making my fractions. I'm going to go small triangle to big triangle. Let's go pink to pink first. On the small triangle, I got a 2, and I'm going to be comparing it to the big triangle, which is 4. There's my pink to pink. 2 divided by 4, I get 0.5. Is that good? I don't know, but it does give me a side. Let's go ahead and check the big sides. I'm going to use the green ones. Green sides, I'm going to go 3 is for the small triangle, and then 6 for the big triangle. 3 over 6, that gives me 0.5 as well. Now I know for sure this is good because I got another side. These sides are proportional, therefore I get the sides. I know these triangles are similar. Be careful when you label these as well. Let's talk about the small triangle. Small triangle are the colors on the inside. I'm going to go um, X, Y, Z. And in that case, I went along the pink side and then the blank side and then green. Pink, blank, green. That was X, Y, Z. I need to do the same thing for the large triangle. Pink, blank, green. So pink would be X, T, S. So I'm going to say triangle X, Y, Z is similar to triangle XTS by side angle side similarity. That is probably the toughest one we're going to do today. Nope, actually, there's one that's a little bit tougher than that one, but we'll take a look at it. All right, on this one, let's see, what do I have? I have, oh, I'm sorry. If you haven't done so, press pause and go ahead and copy down those shapes. And once you're done with those, you can go ahead and press pause, copy down these shapes, and that will finish out the notes for today. It's going to look just like that, okay? I'm going to go ahead and zoom in, assuming that you already did that. Let's see, what do I have? I have 90 degrees right here. I know that's getting split, but I don't know if that's getting split in half. Like, it kind of looks like it might be, but you can't go off of it kind of looks like it might be. That's not going to work. I don't see any arrows. I only see that 90 degrees, and that's it. So on this one, like, we really can't do anything. So what am I going to write? I'm going to write not enough info. Like, I wish there was enough info, but like, I can't do anything with that. That's as far as we're gonna go. So that was pretty straightforward. Let's take a look at this one. I see a bunch of stuff on this one. And one of the things I don't notice are any angles, and I don't think I can get any angles off of this. So yeah, this is not gonna work as far as angles are concerned. But I definitely have some sides. Now the hard part is gonna be knowing which one the biggest sides are, and especially since there's all these radicals all over the place. So what we're going to do is we're going to have to kind of just get an approximation for these things because we want to know which one's the smallest, which one's the biggest, which one's the medium. I see a 3 and a 6, and then I see a 3 square root of 3. So let me go ahead and multiply 3 times the square root of 3 on my calculator. Hit enter, and that tells me that this is around 5.196. Now, that's not the number I'm going to use. It's just a number that I can approximate. So that way I know which one's the. Now that I have that 5.196, like I know, oh, for sure, 3 is the small side. And for sure, 6 is the big side. Which means that 3 rad 3 must have been the medium side because it's around 5.196. Makes it a lot easier to color code these things, okay? All right, let's go ahead and try the next one. Let's see. On the next one, I got a lot of radicals, so let me go ahead and calculate this one. 18 rad 3, plug that in my calculator. 18 times the square root of 3, enter. And I get 31.177, it looks like. Approximately 31.177. And let me go ahead and do 9 square root of 3 as well. 9 times the square root of 3, and that's about 15.88. All right, now that I have these labeled, I know which one's the big side. The big side must be that 18 square root of 3 because it's around 31.17. That's a pretty big number. Smallest number looks to be the 9 square root of 3 because that's around 15.88. Go ahead and highlight that one pink. That means my medium side is going to be the 27. All right, now that I have them color coded, now I can finally go ahead and start setting up my fractions. Remember, this is going to be side, 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 so I need to go ahead and establish all the S's. So I'm going to go take this triangle and compare it to this triangle. I'm always going to take these numbers first, put them on top of these numbers over here. So let me go green to green first. That's going to be 18 rad 3 divided by 6, which gives me, on these ones, we might as well get used to this. Because that's an 18 and because that's a 6, I can actually simplify these. 18 divided by 6, that gives me 3. And I still have that square root of 3 left over. So I'm going to write this as 3 square root of 3. Okay, let me go ahead and do the next one. The next one is, let's go yellow to yellow. So again, I'm going to start with this number and go this way. So I'm going to take this 27 and divide it by 3 square root of 3. And I'm realizing, nope, we're not going to be able to do it exactly like this just because you probably don't have too much practice on this. So let me go ahead and calculate this one then. 3 times the square root of 3 on my calculator, I get around 5.196. Oh, that makes sense because we just did that one above. 3 square root of 3, 5.196. Let me go ahead and calculate this. When you calculate this, you want to put a 27 on the top, divided by, put parentheses, and then type 3 times the square root of 3. Close your parentheses, close them again, hit enter, and you should get that 5.196 again. That's good because so far my sides are matching up. So let's see, so far I have the green side and I have the yellow side. Is that enough? Nope, that's only 2 s's, so I need my third s. The last one's going to be 9 square root of 3 divided by 3. So I'm going to type 9 times the square root of 3 divided by 3, hit enter, and that gives me 5.196 again. I forgot to write it. Let me go ahead and write it. 9 square root of 3 over 3 is 5.196. And again, these are all approximations, guys, but we're getting the exact same decimals, so I think we're actually pretty good right there. Did I get the same thing 3 times? I sure did, so that means I know these triangles are similar. So I get to say triangle EGF is similar to triangle EGF. I went green, yellow, pink. So if I want to go green, yellow, pink, I should go JHI by side, side, side. 4 down, 2 more to go. We're almost there. All right, what do I notice? I notice an angle, so let's go ahead and use that one. Definitely want to use that angle. This angle is congruent to this angle, so I say I got an angle. And then I'm going to go ahead and start matching up sides. So let's see, what can I match up? The small side is 4. And the small side is 8. And then over here, I got the large side is 5. And then I got the large side is 10. And I'm going to tell you what, guys, I could go ahead and start setting up these fractions right now. I'm going to say, wow, these fractions actually work. Except I really don't need to do that because I'm noticing that the triangles are not the same. What do I mean by that? Well, let me go ahead and do the mistake. The mistake would be like, oh, okay, go ahead and get those numbers. 10 divided by 5 is 2. That's green to green. 8 divided by 4 is 2. That's yellow to yellow. You're going to look at them. You're going to say, wow, I got angles, and then I got a side. Then I got a side. Here I have side, angle, side. Except this doesn't work. Why doesn't it work? Because it's side, angle, side over here. And it's angle, side, side over here. And that's donkey. Notice that the angle is not stuck between the two sides. If it was, my angle should be over here. So even though it's proportional, even though the angles are the same, because this is side, angle, side, and this one ends up being donkey, you cannot say that these triangles are similar. So we're going to go ahead and say not enough info. Triangles not similar, not enough info, whatever. Same thing. We don't have enough information to say that the triangles are similar. All right, now we're down to the last one, and this one looks very similar to this one. And so we go, oh, it must be not enough info again. except they gave you a little bit more info, and that changes things. So we're going to go ahead and see if these two little triangles are similar. Now, actually, in this picture, I see three triangles. Excuse me. I see three triangles, but I'm just going to check this triangle on the left right here. I want to see if it's similar to this triangle on the right over here. So hopefully you're seeing the two triangles, the triangle on the left, triangle on the right, triangle number one, triangle number two. Okay. All right. This time they gave me more information. They absolutely did. So what can we do? Well, first thing is I noticed that this is a straight line. That's a straight line, and that's 90 degrees. I know that this thing needs to add up to 180. If this is 90, then this needs to be 92. So let me go ahead and add in this 90. Why? Because 90 plus 90 does give me the 180. So, already I have that this angle is congruent to this angle because they're 90 degrees. So all I need is one more angle, and I can say that these triangles are similar by AA. All right, what else do I have? Well, I see on this top triangle that this is 60 degrees. Look at this triangle right here. I got 60 and I have 90. And if I have 60 and 90, then I should be able to find out this missing one right here by calling it a question mark. Let me go ahead and call that a question mark. That means 60 plus 90 plus question mark equals 180. That means 150 plus question mark equals 180. That means that question mark must be equal to 30 degrees. So let me go ahead and erase this question mark and say that that's 30 degrees. Does that help me? Not yet, but it will, because now I see that this is a right angle. Right angles means there are 90 degrees, and this thing came in and split it so that it's 30 degrees here and something degrees here. So let me go ahead and call that question mark. So again, I'm looking at this 90-degree angle right here, and I know that part of it is 30, and I don't know the other part. So I'm going to go ahead and write 30 plus question mark equals 90 degrees in this case. Subtract 30 from both sides, I get that that question mark is equal to 60 degrees. Oh, is that important? That is important because now that I know that this is 60 degrees, now I know that I have another angle. I know that this 60 degrees matches up with this 60 degrees. So it does give me another angle. I know that they both have a 90, and I know that they both have a 60. So that's enough. Now I can say that those triangles are similar. I got to be careful. So let's see. You know what? Let me go ahead and label this as well. This is 90 degrees. This is 60 degrees. This is question mark. You can use that triangle sum theorem again. It's got to add up to 180. 90 plus 60 is 150. That means this must be 30 degrees so that I get to the 180. All right, why did I do that? Well, it's going to be a little bit easier for me to mark these triangles. So let me call this triangle QTR. When I did QTR, I started at 30, went to 60, went to 90. Triangle QTR is similar to triangle. Remember, I went 30, 60, 90. So on this triangle, I need to go 30, 60, 90 again. I'm going to start at TSR to get that 30, 60, 90. I started writing 30, 60, 90. TSR. How did I know that? By angle similarity theorem. Yeah, that was pretty challenging, I'm not going to lie, but hopefully once you've seen it at one time, you'll be able to replicate it down the road. All right, that is all the information I got for you today. As always, if you have any questions, please feel free to ask.